Hi everyone. Today we're doing an AS pure paper again. So we'll get started. Okay. So the first question is just one of integration, and it's one of these ever so slightly tricky, but not really tricky, ones with a square root or some fractional power. So, when you see something, it's the square root here, it's the power of minus a half, this bracket is. If you see something that's the power of three halves or, 5 halves or something, the same thought process should go through your head. And first we're just going to divide up separate the variables as usual. Take all the x's on one side and all the y's on the other. And I'm actually going to write this as a bracket for x plus 1 to the minus 1/2. And you should recognize that this to the power of minus a half is what you would get if you differentiated something, the same bracket to the power of a half. So I'll show you what I mean. So I'm going to integrate these, and I'm going to use this boundary condition as one of my limits. So remember, there's two ways you can do it. You can either do an indefinite integral with a constant and then plug in to find the constant, or you can use it as one of your limits. So when x is equal to 2, y is equal to 5. And when x is equal to some later x or some other x that's not 2, then y is equal to y of x. I mean, that's what we're trying to find, is the relationship between y and x. So on this side, we've got y of x. And on this side, we've got 8. And then the integral of this thing. So we know that if we had 4x plus 1 to the 1/2 and differentiated this to go back up there, a half would come out. So we have to compensate for that by supplying a 2. And then also a 4 would come out. So we have to compensate for that by supplying a 1/4. And if you just satisfy yourself that that would reproduce the original integrand, and this is being evaluated between 2 and x. So that's going to be, that becomes 1/2. So the whole thing becomes 4 in front, becomes 4 times 4x plus 1 to the 1/2 minus 4 times 2 is 8, plus 1 is 9, and then it's the square root of 9, so it's going to be square root of 9. Oh, forgot to say on the left-hand side that should be y of x minus 5. Whoops, silly mistake. So this gives us that the y of x, and then we take the 5 over, is 4 square root 4x plus 1 minus 4 square root 9 plus 5. And that's the final solution. Well, actually, the final solution would be to replace that by 3, and then this last bit becomes minus 12 plus 5, which is minus 7. Okay, the next one's trigonometry. And they just want us to use the trigonometric identities, which are all in the formula booklet. So just once you're used to using them, you'll know which ones to use. Usually you'll be wanting to get things all in terms of one of the trigonometric functions. So let's look at this here. We've got sine 2x plus 3 cosine 2x equals 3 sine 2x minus cosine 2x. So firstly, let's rearrange. Let's pull all the sine 2x's together and all the cosine 2x's together. Usually when you see a 2x, you want to expand it into just the sine and the cosine of x without the 2. I'm using the formula booklet, but in this case, we don't have to, because everything is cosine of 2x or sine of 2x. So we can just leave it as that for now. So sine of 2x, so on the left-hand side, let's say we keep this 3 cosine 2x minus, we've got a minus cosine of 2x on this side, comes over, becomes plus, so that's 6 cosine of 2x is equal to, and then we've got 3 sine of 2x, and then this is minus 1, so that's 2 sine of 2x. And using the identity that the tan of theta is equal to sine of theta over cosine of theta. We divide both sides by cosine of theta, and we get that the tan of theta is equal to 3. Now, the slightly tricky bit comes here in the next sub-question, which is to solve the equation for x between 90 and minus 90. So this is one of those where you have to basically draw the graph and realize how many solutions will exist. So the tangent function looks like this, with that being 90 and that being minus 90. So the tangent function has a periodicity of 180 degrees rather than 360 degrees. So sine and cosine, they repeat every 360 degrees, but tangent repeats every 180. So this is what it looks like. It starts at 0, heads up to infinity, and then at the bottom here it comes from minus infinity, and continues. So we're only interested in this middle bit here. Well, we're told that the tangent, so the y-axis is the tangent of theta, that when for what values of theta is the tangent equal to 3? Well, 3 is around, say, here. So it's going to be one solution there. And that should be the only solution. Have I done this right? Right. Oh, no, yeah, I made a mistake up above. I'm sorry, no one, I'm confused. This is, I shouldn't have gone the tan of theta. This is the tan of 2x is equal to 3. Okay. So we're told that the tangent of 2x is equal to 3. So if x is between minus 90 and 90, then 2x must be between minus 180 and 180. So I'm actually looking for 2x. So when you've got this kind of thing, you know that the trigonometric functions are periodic. They're periodic in whatever their argument is. So in this case, they're periodic in 2x, not especially in x. So always do all of your stuff with in terms of, you can just call, theta is equal to 2x, and then you can just do all your business with theta, and then at the end, then only replace it back with x. So we're looking at all of this possible places, possible range, and here's one place where the tangent would be equal to 3, but there's another one over here. So first you'll take a calculator and you'll say, okay, theta, which is 2x, is equal to the inverse tangent of 3. And that will give you the answer 71.6 degrees. And then you also know that you can get 3 if you make it minus 180. So this is minus 180 plus 71.6. So this distance is the same as this distance. So you can obtain the other solution that way. And so the other solution is minus 108.4 degrees. And now you can therefore go that x is equal to, and then you just divide by 2. So don't let get confused by the x and the 2x. The thing, just call 2x theta, do your thing, and then divide by 2 at the end. Otherwise, you will probably make mistakes. Okay, question 3. Right. So we have a curve has this equation, and we want to know the set of values of x for which y is greater than 13. So what does it mean for y to be greater than 13? Well, this is equal to y, right? So we have the equation that 2x squared minus 6x plus 5 is greater than 13. And then we rearrange, and we'll get that 2x squared minus 6x minus 8 is greater than 0. And I can factorize this. And I can factorize it pretty easily and exactly. And you see that the roots are at x is equal to minus 1 and x is equal to 4. Now, that doesn't mean, you know, that these are the two roots that would solve the equation where this whole thing is equal to 0. So they obviously form the boundary of the allowed region, because this thing always has to be greater than 0. So when it's equal to 0, you will reach the lower boundary. So what kind of parabola do we have? Well, if you look at the coefficient of the initial one, you'll see that we must have a smiley parabola. You know, it's going to look like that. Oh, going to look like that. I don't know what's up with this pen. It's always doing this, but I'll try and work a bit slower, more slowly. So it looks something like that. So it's going to be crossing, okay, it's going to be crossing the x-axis at -1 and at 4. And we're being told that y, which is the curve, has to be greater than sorry, this curve has to be greater than 0. And that's over here and over here, i.e. when x is less than -1 or x is greater than 4. So you have to be a bit geometrical to work out which way it was. You might naively think that this means that x has to be between -1 and 4, but actually that's the place where it's this curve here is negative, this guy. So that's how you get the answer. Okay, find the value of the constant k for which this line is a tangent to the curve. So what does it mean to be tangent? Well, it means that, well, there's a couple of ways to do that, but let's say we're going to solve for the meeting point of these two lines. We're told that it's tangent, or that we want it to be tangent. So we can. How do we solve for the crossings of two curves? Well, we set them equal to each other. So we have the 2x plus k is equal to 2x squared minus 6x plus 5. And if we just rearrange this into a normal-looking quadratic, we get that 2x squared minus 8x plus 5 minus k is equal to 0. And what is the requirement for a tangent? Well, tangent is the same thing as saying that the discriminant of the quadratic that we form by setting them equal to each other is equal to 0. And if that sounds a bit weird to you, then maybe go back and look some of the previous videos where we talk about it in more detail, but essentially it means that there is one meeting point. So there's only one solution. And for that, the thing under the square root in the formula, the quadratic formula, needs to be 0. So what is del? Well, it's b squared minus 4ac. So that's 8 squared minus 4 times 2 times 5 minus k is equal to 0. And if you solve this, you'll get that k is equal to -3. Okay. Question 4. So we're being asked to expand a polynomial. And there's a couple of ways that you can consider doing this, but because it's to the power n here, and you're not told of anything about n, so you can't make any assumptions. So you're going to have to use in fact, you know, you technically should use Taylor's expansion, which is the one you would use when you don't know anything about n. But you never need to use Taylor's expansion in AS. They always mean using the polynomial expansion. So n, they're saying that n is a positive integer, but they haven't actually said that. So that's actually very naughty of them. That's very sloppy. But we're going to use they obviously mean that n is an element of the positive integers. That's how that's written. N, in fact, there's no is. N is in the positive integers, as they say in mathematical notation. So what is if we use that formula that's in the formula booklet, this is what our thing looks like. We have 1 plus n choose 1 x over 2 plus n choose 2, oops, no line there, n choose 2 x over 2 all squared plus and so on. And we just want to find the coefficient of x squared. So that's going to come either from a combination of this thing with a single x and this thing with a single x, or this thing with a constant and this thing with an x squared. And those will both give us x squared terms. So the coefficient, oh, right, sorry, that's the second part of the question. We're told that the coefficient of x is 7. So we're going to use this to find out n. So the coefficient of x is 1. Let's take those away. So either you're going to get them by this constant times the x term, or from this x term times, times the constant. So the coefficient of x is minus 2. This is the first half of the question. Minus 2 plus n choose 1 times 3 times 1/2. And we're told that this is equal to 7. And if we expand out n choose 1 using the formula in the formula booklet, we get that minus 2 plus 3 n factorial over 2 n factorial n minus 1 factorial. Sorry, 1 factorial, which is just 1, n minus 1 factorial. Now you can see that if you have n factorial over n minus 1 factorial, all you're left with is n, because you're multiplying everything below n together. And here you're multiplying everything below the 1 before n. So when you divide by that, you're going to get n. Convince yourself it's true, that it's like 3 factorial over 2 factorial is equal to 3 times 2 times 1 over 2 times 1. And you're just left with a 3. So everything else cancels. So this is equal to minus 2 plus 3n over 2. And this will give you that n is equal to 6. So now, in the second half of the question, we get the coefficient of x squared. And that's going to be the combination now of this x term and that x term, and this constant term and the x squared term. So that's going to be n choose 1 x over 2 times minus 2x plus 3 n over 2, n choose 2, sorry, times x over 2 squared, which is, gives you a coefficient. So that's going to be the x squared term. So that if we take the x squareds away, because we only care about the coefficient, we get 6 factorial over 5 factorial minus 6 factorial over 5 factorial plus 3 times 6 factorial over 2 factorial, 4 factorial, 1 on 4. And this will give you 21 on 4. So just purely applying, using the expansion and applying this formula for the choose, n choose k notation, and realizing that you don't have to multiply everything out. You don't care about this 3 that you get from 3 times 1. You just care about the coefficients of the relevant terms. Okay, question 5. So we have some curve here, some line, and another line here. And we're told that there are these 2 points, A and B, which are the x and y intercepts of this first curve. So I'm going to just draw schematically something like so. I'm going to say that's A and that's B. And there is some line AB between them. And there is some midpoint here. So I'm going to say that A has the coordinates A, little a comma 0, and B has the coordinates little b comma 0. Then the midpoint line must have the coordinates A over 2, B over 2, because we've got halfway along and halfway down. Okay, so we're told some other facts now. we're told that that this midpoint M lies on this second line. So we can plug, so this gives us one piece of information. So we're solving for two, actually I shouldn't call that, yeah, okay. So the reason why I'm calling this little a and little b is because you can see that if I set x to 0, then y is equal to b, and if I set y to 0, then x is equal to b. So the a and b are the same. They're the same ones. So I'm solving for a and b. I need two equations to do that because I've got two unknowns. So my first equation is that this midpoint, these coordinates of the midpoint fit this line. They satisfy this line's equation. So that means that 2a over 2 plus b over 2 is equal to 10, which I'm going to rephrase as b is equal to minus 2a plus 20. And the second piece of information I'm given is that this line AB has a magnitude of 10. Well, what is the line AB? How do I get that? Well, I know that the length of it is the hypotenuse of this triangle here. And what is this triangle? Well, this side, it's a right angle triangle. This side has length A and this side has length B. So the hypotenuse is a squared plus b squared. So the length, so hypotenuse squared is a squared plus b squared. And this is equal to 10. So this gives me that if I plug in for b with this b that I found there, I get, so I got a squared plus 4a squared minus 80a plus 400 is equal to 100 because I'm squaring both sides of this here. And this will give me, if I juggle things around, I get that a squared minus 16a plus 60 is equal to 0. If I solve this using the formula, I'll get that a is equal to 16 plus or minus square root of 16 squared minus 4 times 60 all over 2, which is either equal to 10 or 6. In this case, if I plug that back into here, I will find that b is equal to 0. But that's not allowed because I'm told that a and b are positive constants. So this solution doesn't count. However, if a is equal to 6, that means that b is equal to 8, and that's a perfectly fine solution. And in fact, the only solution. Okay, question 6. So this is just a lot of geometry and just being a bit careful about how you estimate lines and, deduce the values for the lengths and circumferences. Just, take your time. So they want us to show that the radius of the semicircle is this value. So what we're looking for is this length here. So the way I'm going to do that, oh God, that just looks awful. Let me use this color. So the way I'm going to do that is to divide this into, and you can see it's an isosceles triangle. The whole thing is an isosceles triangle. So this thing bisects this angle. So each of these little angles is now going to be 0.6 radians. And now I have a triangle. I just have this right-angled triangle with a hypotenuse of 10 and a lower angle of 0.6 radians. So therefore, this is my the radius of the small circle, which is just going to be 10 sine of 0.6. So 10 sine of 0.6, which is just equal to what they wanted. Okay, now they want us to find the perimeter of the metal plate. So that's going to be equal to the perimeter of the big circle minus the missing piece plus the perimeter of the smaller piece. So this one is 2 pi big R is the circumference of the big circle, minus, and this is an arc length, and we're talking about the angle subtended by, sorry, the arc length subtended by an angle of 0.6 degree radians. So we're allowed to use the formula which is in the formula booklet. Remember, this only works in radians, and it's r, it's the radius times the angle in radians that that the thing is subtended by. Plus, and then again, this is just an arc length, right? And it's subtended, sorry, this is just like a semicircle. Yes, so it's a semicircle, so you can just think of it as pi times little r. And we know that big R is equal to 10 centimeters, and little r is equal to 5.646. And you can just plug that in, and you get that the perimeter is equal to 68.57 centimeters. So I would recommend writing it out pictorially like this. Then you can keep track of all the different bits. Okay, now they want us to find the area. And again, I'm going to do it pictorially. So the area of the metal plate is going to be the area of the big circle minus the area of the missing wedge plus the area of the triangle, because it's not like the whole wedge has gone missing, so that this slice here, that it's just that section, this little bump that's gone missing. So I'm subtracting the entire wedge, but then I'm adding back in the triangle, and then I'm adding the semicircle on top. So this guy, what's the area of him? Well, he's obviously pi big R squared minus, and then we can use the formula booklet to find out the area of a slice that's subtended by an angle, and it's 1/2 R squared times the 1.2. Oh, the same thing was true here. That's really dumb. That should have been 1.2. Apologies. So yes, 1/2 R squared times the angle plus this triangle. Well, that's going to be 1/2 times base times height. So it's 1/2 times 2 times 5.646 times the height, which is going to be 10 cosine. It's the other side of that initial triangle we got at the beginning, 0.6. It is 0.6 this time, plus the area of the semicircle, which is just pi on 2 times 5.646 all squared. So half of a circular area. So if you plug all of this in with r's, you'll get, it'll be something like 100 pi minus 60 plus 46.60 plus 50.07, giving you an answer of about 351. So again, the pictorial thing is very helpful to keep track. Okay, question 7. So we're given the equation of a curve, and they just want us to differentiate this first off. So this is just mechanical. If you're looking at it and going, what the hell do I do? Then you should practice some basic differentiation. But the important thing is just to go carefully, and then you shouldn't be able to make a mistake. So dy dx, the first term disappears. And the second term is 3 times 2 over 2x minus 1 times minus 1. So we're differentiating this bracket, 2x minus 1 squared. So this bracket, we get a minus 1, and then it picks up a squared. We get a 2 from the inside. So that's minus 6 on 2x minus 1 all squared. Now that we need to explain why the curve has no stationary points. Well, a stationary point, That's the same thing as saying that dy dx is equal to 0. Now, how do you make this thing equal to 0? You can't, right? It literally doesn't have any way that it can. Minus 6 is less than 0, and 1 over this bracket squared is strictly greater than 0. It can never be equal to 0. You can't divide 1 by anything except infinity, I guess, and expect it to go to 0. So the curve kind of has a stationary point at infinity, but that's not a real point. That's not a real number. That doesn't count. So just say that you cannot solve with dy dx equals 0 because the curve has no stationary points. So now we're looking at a specific point in the curve x equal to 2. So this means at that point, y is equal to, if you plug it in, you'll find y is equal to 3. And dy dx, if you plug it in, is equal to minus 6 on 9, which is minus 2/3. And now they want you to show that the normal at P passes through the origin. So that means we have to find the equation of the line that is normal to the curve at P. So remember that if it's normal, it means that the product of the gradients is minus 1. So that means that our m here for our straight line, our normal, is going to be 3 halves. So that gives us, at the moment, the equation y is equal to 3 halves x plus some constant c. And to find out the constant, we need to know one of the points that the line passes through. And we do, it passes through P, and we already got the coordinates of P. It's 2, 3. So we get 3 is equal to 3 plus c. So c is equal to 0. So our equation is y is equal to 3 halves x. And that means when x is equal to 0, y is equal to 0. So it passes through the origin. Okay, last bit of this question. Sub-question 4. So we have a point moves along a curve. So we're talking about a rate of change of things in terms of time. So we're told that the x-coordinate is decreasing at a constant rate of 0.06 units per second. So what does that mean? It means that dx dt is equal to minus 0.06. It's getting smaller, and that's how quickly it's getting smaller. Now they say find the rate of change of the y-coordinate. That just means dy dt. And so for this, we use the chain rule. Dy dt is equal to dy dx, dx dt. And we already know dy dx at P. If we look up here, that was exactly what we worked out before. It's minus 2/3. So this is minus 2/3 times dx dt, which we're given, minus 0.06. And that is the answer you require. Just multiply it together with your calculator. Okay, question 8. So this is a differential equation question. Our first task is to build the differential equation. So you just have to be a little bit careful here about the way you measure time. So I'm gonna use time t to mean number of days. So I'm going to talk about his velocity as a function of time. And now if there's going to be some initial sort of starting value, and then each day he travels on from May the 1st, this will decrease. So this is what you construct. It decreases by 5. But you have to be careful. It's not 5t, it's 5t minus 1. Because on the first day, he's traveled a sort of number of days elapsed. So on the first day, he's traveled 200. So we want this thing. In fact, let's call it the date. You could do it in different ways. You could talk about like the number of days elapsed since May the 1st, but then you're welcome to do it that way. I've chosen to do it this way. So I'm going to say the time t is sort of the date So on the first, you get t is equal to 1, 1 minus 1 is 0, and he travels at 200 kilometers. Sorry, not 200 kilometers. Yes, 200 kilometers. So I'm calling this velocity kind of the velocity per day, not sort of instantaneous velocity. Obviously, it's like 200 kilometers per second or anything, but it's 200 kilometers per day. So on the first day, t is equal to 1, so this is just 200. On the second day, t is equal to 2, so it's 2 minus 1, which is 1. So you subtract 1, 5, and so on. So you want to know what date he will, how far he will travel on May the 15th. So you just plug in 15, and you get 200 minus 5 times 15 minus 1, which is 14. And this gives you 130 kilometers. And now they want to know what date he will finish the event. So now we need to integrate. So I'm going to know that v is just distance, the rate of change of distance over time. So I'm going to define some ds is therefore v of t dt, which is 200 minus 5t plus 5. I've just expanded out the bracket, which is 205. So this is dt, 205 plus minus 5t dt. And now I'm going to integrate this and integrate it between the initial, like 0 days past, where he traveled 0 kilometers, to some later number of days, t, where he's traveled 3050 kilometers, i.e. when he's finished. So the left-hand side just becomes 3050. And the right-hand side, integrated, 205t minus 5 halves t squared between 0 and t. And this will give you the equation, quadratic equation, obviously, t squared minus 82 plus 82t plus 1220 is equal to 0. And this will give you two answers for t, 41 plus or minus square root 461. But obviously we want the smaller one. So the smaller one, as long as it's not negative, the smaller one will come first. So we know that'll work. And this will give us t is equal to 19.53. And obviously this is going to happen on the 20th day. Because it's above 19, so you round it up. You can't round it down. He's already gone into the next day. So each one, the date means like at the end of that, when I mean t is equal to the date, I mean at the end of that date, how much has he done? And at the end of 19, he wasn't quite there yet, but at the end of 20, he will be done. He'll be done halfway through day 20. Anyway, you get the idea. Okay, so the next one is about a geometric progression. So in fact, the first one you could have used, I used integration. You could also use summation of a arithmetic series. Yeah, it's actually, I think, the one that you use in the solutions. So you're welcome to use that as well. But this one is definitely a geometric progression question. So geometric progression looks like this. So the first term has no r, second term has, AR. That's just r to the 1, sorry, that's squared. So the second term has 1 power of r, the third term has 2, the fourth term has 3. So it always has 1 less than the number of the terms in the series. So each term gets multiplied by r. So they tell us 2 pieces of information. They first tell us that the third term is 8 times the sixth term. So that means that AR squared is equal to AR to the 5th times 8. So this means that r cubed is 1 on 8. So r is equal to a half. Great, it's a convergent geometric series because r is smaller than 1. And now they tell us that the sum of the first 6 terms is 31.5. So we use the formula booklet to get the how to get the sum of the first 6 terms in a geometric series. And it looks like this. And this is equal to 31.5. And if you solve this, you plug in for r, you get that a is equal to 16. And now they want us to sum to infinity. So that's also in the formula booklet. You can just look that up. You know a, you know r, you can get the whole thing. Okay, question 9. Vector question. So this is all about dot products, this question, or scalar product. That's another word for it. Dot or scalar. And it's called a scalar because what you get out is a scalar, you know, and just a pure number. There is another thing called the vector product, but you don't have to worry about that. So that's just why they don't just say product. They actually clarify that it's scalar versus dot. They're 2 different types of product. Don't worry about there being 2 different types of product. So we've got these 2 vectors, and they want us to find the angle between OA and OB. That's the angle, you know, if that was A, and I'm not saying they are, I haven't actually looked, you know, I'm not plotting them correctly, but if that happened to be A and that happened to be B, then the angle is the one between OA and OB. And you got to know that the dot product is of that V dot W is equal to magnitude of V times the magnitude of W times the cosine of the angle between them. So in this case, we've got that OA dot OB is equal to the magnitude of OA, which is square root of 4 plus 4 plus 1, which is, you know, the square root of the sum of the squares, you know, the Pythagoras, basically, in arbitrarily many dimensions of the components of this vector, and times the magnitude of OB, which is 4 plus 9 plus 36 cosine of theta, and that's equal to the dot product of the 2 in terms of their components, which I'm going to write like this. And that is like minus 2 times 2 is minus 4. Just do them component-wise. 3 times minus 2 is minus 6. 6 times minus 1 is minus 6 again. And so this is a number, this is a number, this is a number. We can get that that the cosine of the angle is minus 16 on 21. And therefore, just put in your calculators, then the angle is 2.44 radians. Okay, now they want the vector, which is in the same direction as AC and of magnitude 15 units. So you should just be you know, familiar and used to the idea of resizing a vector by scaling it by some amount. So the first thing we need to do is we need to know how long AC is anyway, because, I mean, the vector parallel to it is just going to be some scaled version of it. That's the whole thing about vectors. If it's parallel, it means it looks exactly like it. It's just got some scaling factor. So what is the magnitude of AC? Well, AC is just OC minus OA. Convince yourself that's true. Because in order to go from A to C, you have to go back from A to 0 and then forward from 0 to C. And this is going to be the magnitude of, if we look back up here, that's 2 minus 2 is 0, 6 minus 2 is 8, and that's 6. So this is the square root of 8 squared plus 6 squared, and that's just equal to 10. So that means that our vector, which is going to be some number times AC. Well, first I'm going to divide by the magnitude of AC, and then multiply by the magnitude I want, times 0.86. And that is exactly the thing. So if you took you know that this is in the same direction as AC, because it's just some number times AC. And if you took the measurement of its its magnitude, you would find that its magnitude would be 15. So now we want the value of some constant for which this line here is perpendicular to OB. Well, what is this line? I'm just going to write it out. It's going to be 2p plus 2 minus 2p plus 6 minus p plus 5. And we are dotting this with OB, which is minus 2, 3, 6. So this gives us, and if you multiply it out, you'll find that it gives us, let's see, 2p plus 2 is, 2p plus 2 times minus 2 is minus 4p minus 4. 3 times minus 2p plus 6 is minus 6p plus 18. 6 times minus p plus 5 is minus 6p plus 30. And we're saying that these two things are perpendicular, so this must be equal to 0, because the cosine of 90 degrees is 0, so the dot product must vanish. So this gives us that p is equal to 2.75. Okay, last question. So we have some function f, and we want the range. The range, you have to just be a little careful with this one. We know that that x can only be between 0 and pi. So your initial thought might be to test what you can get out of f if you put in 0 and pi. So f of 0, that's going to be 5 minus 2 times the sine of 0. So that's 5 minus 0, which is 5. But if you test f of pi, you'll find that it becomes the sine of 2 pi, which is also 0. So this is equal to 5. So this can't be the range unless f is always 5. So let's think about this sine of 2x. If x is running between 0 and pi, then 2x must be running between 0 and 2 pi. Oh, this pen drives me crazy. 2 pi. Well, what does the sine function look like in that range? It looks probably nicer than that. So we see that at 2x is equal to 0 and 2x is equal to 2 pi, i.e. x is equal to 0 and x is equal to pi, they are the same at 0. But meanwhile, they go up and down. So this function has its maximum at when sine of 2x is equal to 1, when 2x is equal to pi on 2, and has its minimum when 2x is equal to 3 pi on 2. So that means that the maximum of this term here, which is therefore going to mean subtracting bigger things, is reached when when x is equal to pi on 4, which means that 2x is pi on 2. And that'll give us a sine of 2x of 1. And that means it's 5 minus 2 times 1, which is 3. And if we put in x is equal to 3 pi on 4, so 2x is equal to 3 pi on 2, we get sine of 2x is equal to minus 1. And therefore, this is equal to 5 plus 2, which is 7. So we see that actually f of x ranges from 3 to 7. It goes both above and below 5. And the 5 thing is just a naive application because sine is periodic. So now they want us to sketch the graph. And of course, we're going f of x is a function of x, and x can only go between 0 and pi. And it's going to start at 5 because that's f of 0. And it's going to end at 5. And it's going to have a minimum at pi on 4, and then a maximum at 3 pi on 4. So it's going to dip down and then up again. So it's going to look like this. And here it's going to be 3, and up there it's going to be 7. And that's it. That's the entire graph. So now we're going to solve f of x is equal to 6. So that means that 5 minus 2 sine of 2x is equal to 6. So that sine of 2x is equal to minus a half. And remember, always solve for the thing that's actually inside the trigonometric function first, and then go to x, whatever your final x wants to be. So this is the graph of sine of 2x. And we see that that it's equal to minus a half here and here. So if we put it into our calculator, we'll get at this point. If we put it into calculator, actually, you will get the point over here, because they give you the one that's closest to the origin. But then you just, yeah, okay. So if you put it into a calculator, you get the point minus pi on 6, but that's not even in our range. So we'll want to take this distance here, which is pi on 6. And it's the same as this distance here and this distance here. So we know that if we take pi plus pi on 6, which is 7 pi on 6, that'll give us a good solution. And this one is going to be 2 pi minus pi on 6, which is 11 pi on 6. So this means that we have these two solutions for 2x, these two solutions for 2x, therefore x must be equal to 7 pi on 12 or 11 pi on 12. Okay, now we're given another function, which looks the same, but we're asked to find the largest value of k. So we're asked to find a value that x is allowed to, like the domain of the function, and we want g to have an inverse. Well, inverse means that the function g is 1-to-1. So it cannot repeat itself. And the problem with these functions, like trigonometric functions, is that they repeat themselves. That's why we get these several different solutions. So if I'm looking for a place where the sine of x is equal to a half, here's one, but here's another one. And in fact, there's infinitely many. So I'll have, if I want it to be unique, 1-to-1 mapping, I have to restrict myself to this bit. So within this section, it's unique. Every value of y is mapped to exactly one value of x and vice versa. So I have to restrict my range to when 2x is between 0 and pi on 2. So let's say this is 2x. And therefore, when x is between 0 and pi on 4. So if this is the value of k, they want us to have an expression for g inverse. Well, this is just the technique that you do where you write down the thing with y is equal to, and then you switch the x's and y's. So we have y is equal to 5 minus 2 sine of 2x. And this becomes x is equal to 5 minus 2 sine of 2y. So sine of 2y is equal to 5 minus x. So 2y is equal to inverse sine of, 5 minus x over 2. There was actually a 2 there. So y is 1/2 inverse sine 5 minus x over 2. And there you go. That's the end of this paper. I hope it was all clear for you. Let me know if you have any questions, and I'll see you next time.